Hello, this is Aedan and Ahmed Jaheen presenting on our Milestone 1 for our project in advanced machine learning. And we are doing a project on Arabic language classification. So the goal of our project is to learn how different techniques and tools can be used to either deteriorate or improve a model's performance. And yeah, we're not trying to invent the wheel here, but just for our own development, learning what these things, concepts we're learning in class, and how they affect models in Arabic text language classification. Related works, we've surveyed three models, the hybrid CNN with bidirectional long short-term memory CNN and RNN with attention mechanism, and other pre-trained models. And the results for different models show that the highest accuracy model is GoogleNet, which is what we're going to be basing our model on.
And the key changes for our baseline model, first, we're gonna use some regularization techniques and the learning date schedule for dynamic changing, so we can reduce the overfitting, and we are going to test different pre-trained models and evaluate accuracies on these data to show which one would perform better on our dataset and in general would be more than enough. And we're gonna fine tuning the best pre-trained model between what we're going to use, and then we're gonna continue with using the vision transformer models, and we're gonna use adapose and sample classifier at the end too, and we're gonna implement different data augmentation techniques to increase the generalization for our model and the difference between different labels in our models. So first, we deployed the baseline model. We managed to deploy the baseline model by training it on HAWP dataset, which is Arabic handwritten dataset. And we have gone through a hard time to train the model on this dataset because we weren't able to find this as a whole, but rather than we only found the updates label and we had to match each image with its new label. So it was like difficult time for us to train the model on it. And of course, the weak GPU on training this model. And finally, we use the official Torch Vision implementation of Google. Okay, so when we run our baseline model, we got the results in our new data set where the change accuracy was 93%, validation 92, and those are accuracies. And you calculate it through the weight versus unweighted for each of our testing to test the balancing between our labels. And this was the confusion matrix. And then findings after deploying our baseline model, we got like the accuracy was like 3% lower than the reported accuracy, and we got a possible reason that we used another data set with different labels. And the second step that there were predicted labels different from the true label, and the most frequent letters were the ha, ain, and waw. Were misclassified, and a possible reason might be that these classes are similar in writing in Arabic language and have different shapes. And a possible solution will be data augmentation. And additional work that we use data augmentations in adding L2 for regularization and retain the model, and finally adding a learning technique scheduled to dynamic adjust learning rate. After reviewing the baseline, we did the data augmentation by added 100 image in the Ain and classes by increasing the link thickness and applied rotation to all the wow images. This is before the augmentation. After that, we found that the training accuracy increased and other accuracy increased too, as shown in the confusion matrix. and it greatly enhances the overall performance. However, the difference between the training accuracy and validation accuracy was somehow increased, so we need to increase the generalization of this model. And the performance on Aedan and Wow were better. However, this model still wasn't able to classify the hat, so we are gonna try different implementation techniques. And to address the issue of generalization, we added L2 regresser with gamma 0.1 and step size 7. Why these numbers? Experiment different numbers and we found this the best numbers we can use in that model. And this was a training accuracy and validation testing, which enhanced a lot after what we have did. And the regression have been reducing the overfitting as a model. However, the model is unable to classify the different labels.
And for the way we're gonna handle noisy labels, we'll be using the joint negative positive learning noisy label handling method, which is basically we're using negative learning and positive learning simultaneously to improve the performance of our model. And for milestone 2, we're gonna try some different and the final, we're gonna try some different data augmentation techniques and maybe create a proposed CNN architecture and train on our data, fine tune some hyperparameters, try different pre-trained models and evaluate those accuracy. And then, of course, trying to see how the GIN PL noise handling method works. And use vision transformers for image classification. And deploy a model on a website with good user experience. Yeah. Thank you.